Welcome back to Holistic Developer. I hope you're having an amazing time working on something interesting, something that gets the wheel spinning, moments where you're like, that doesn't work, and then you get the aha moment and everything seems to be amazing, right? So yeah, today I want to talk with you about something really important that all the software engineers should follow, and those are top 5 programming principles that all software developers should follow. And first, let's start with answering the question, what are really programming principles? And I'll address my friend here, Google, and see what Google has to say. Okay, Google, what are programming principles?
On the website en.wikibooks.org, they say, computer programming is the process of writing, testing, troubleshooting, debugging, and maintaining of a computer program. Good programming practices mix art, craft, and engineering discipline.
Okay, thank you, Google. And I also went to the extent and checked wiki pages to see what does it say. And what it does it say that it's programming principles are rules and affirmations applicable for software engineers. And they're basically, simply put, there are some rules and guidance that we as software developers, as programmers, have to follow in order to have best practices. And as software developers, our job responsibility is to write code that solves a specific problem and provides a specific output. But that's not the only job responsibility that we have as software engineers. We actually have to write code that is maintainable, extendable, and easy to understand. And if a person who will end up in that code, either maintaining it, reading it, or just getting to know, looking for example or something like that, we need to make sure that it's easy to understand. And there is a quote that our VP of engineering loves, and it says, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Yeah, so in that case, you definitely will write an excellent code that is easy, super easy to read, right? So yeah, make sure that we have to write something that is easy to maintain. And even if we are in the moment right now, that's understandable to us. In half a year, we can come back in the same code. We wrote it and something won't make sense. Top 5 software engineering principles that I would like to mention in this videos are as follow. The very first one are the solid principles. And the solid principles are object-oriented design principles that were introduced by Robert Martin. And he's also known as Uncle Bob. Later on, Michael Feathers introduced the acronym itself, the SOLID acronym, which stands for Single Responsibility Principle, Open Close Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. And all of these principles stand for creating and having a code that is maintainable, easy to extend, flexible, and easy to understand. The next principle is the KISS principle. And we as software developers, software engineers, we love to program something new, to develop something great, something interesting, to create, right? We are creators. And the opposite is to actually spend time debugging something or maintaining a complex code. Therefore, this principle stands for keep it simple, stupid, or keep it stupid simple. One of the two. I always mix them. I believe it's keep it stupid simple. And it's self-explanatory, right? You should write software that is easy to maintain. So the best system work best if they are implemented simple and straightforward. So therefore, the recommendation for you is to implement something simple and easy to understand. You understand it now and you will understand it 10 days from now and 10 years from now. And the same is true for the people who will be in that code. And you might be wondering, well, I am working on something complex, then break it down into something simple to understand. Because there's a quote that says that the purpose of software engineering is to reduce complexity and not create it. So whatever you're implementing, whatever you're working on, the project that you're solving, the project that you're generating code, and you're brainstorming, whatever you're doing, make sure that you are making something simple and straightforward. You don't have to overthink anything about it. And I'll probably talk about an example after I talk about other principles regarding this, but I want to add. The next one is dry, the principle dry. And a lot of times we might have something that we need to solve and already a code exists for that. And I was like, oh, I'll copy it and paste it from this place to this place and it will work. And it's great, right? I don't have to rewrite anything or something like that. So in that case, if you do that, you will have a longer code, you will have duplicated code, and if you have to change code in the future, you'll have to change the code in multiple places, and you'll have to remember all the places where the code existed. So you have more complex code that you have to maintain. So the principle says to not repeat yourself. So whatever you are implementing, make sure that the code, the logic exists in one single place, in one common place. Yes, it might take a little bit of time initially to refactor something so you can extract the code and put it in a common place versus just copying and pasted it where you need it. But further the line, it will be much harder to remember all the places where you have to update it. And if you forget one place, then you are creating bugs in your system, which we all want to avoid. So don't repeat yourself. The third principle is YAGNI. I don't know how to pronounce it. So what does that principle stand for? As software developers, again, we love to work and create something cool, something better, something that is never done before, something that is more and more and more, right? And we might fall into the trap that we always want to make something better and something more interesting, more cool, right? And we might get into the fact that we will never finish. And the other thing is that you might not need that. Things change, and one thing that you can count on is change. So you should not implement something that you believe you will need it in the future. So that's what the principle stands for. You aren't going to need it. So make sure that whatever you're implementing, the project that you're working on, do not fall into the trap of saying, oh, wouldn't it be great or awesome to add that? Wouldn't it be great if we could do that? Because if you do that, you might end up having code that is not executed, is not needed, or you have a larger code base again that needs to be maintained, bug prone, and it could be also that it will never be needed. So make sure that whatever you implement what is necessary, and don't implement something until that thing is necessary. Finally, we got to the last principle, the fifth one, which is SoC, and it's a principle of segregation of concerns. And it stands for a division of concerns when the application is complex. So each single section that is part of the more complex application, it's responsible for one job and is independent. Therefore, when there's a project, a larger project, the application has to be developed, multiple people can work at the same time because it's independent, right? Each single section is segregated separately. And what I would like to say there is that it's an example, right? What can it be? It can be that you're working on the same project and something is front end, something is dealt in back end, something is data storage, but from the perspective, from the higher level, everything is one application, but there are different parts that can be worked in parallel without having it interfere with each other, and at the end they should be working seamlessly. Okay, those were the top 5 software engineering principles that I wanted to mention. And I wanted also to give an example. So to keep it concise and simple, I will talk about the KISS principle. A while ago, my team, we were working on a pretty high level project. And initially we implemented something that it's a pattern that we had, right? It's a pattern that we constantly used over and over at our company. And then our director of engineering decided to change things around a little bit, and what we end up implementing was something super elegant, something cool. And honestly, it took me a while to wrap my head around it. And I had a piece of paper where I had all the classes, the diagrams, and I had an UML drawn for the project on a piece of paper to understand how each class were interfering with each other, how they were, what were their responsibility in the larger scheme of things. And every time I needed to do something, every time I was taking a user story to implement something, I needed to look at the diagram to understand where and what needs to be done. And I really like that. It was a great learning experience for me. It was really challenging and I really liked it. And when we finally were done with that project, it was super cool and everybody was excited and looked at it and like, oh, nice. Then a month after it went to production, actually after a month it went in production. It was not a month in production. So once it got into production, the person who had to look into it, there was a question or something like that. The very first thing, he started to look at the code and tried to understand what's there and could not understand what is where and what. So they came back to us trying to understand what it is. So our director of engineering was explaining the implementation, the design, and so on. And then, and again, and again, and again. And that happened multiple times when we had bugs. Then another person come in to look at that screen and could not understand what needs to be done. And the solution was elegant. The design that was done, it was amazing. The architecture was the best. The thing was that it was so out of ordinary for our software. It's not something that we used to do. And trust me, our developers are not stupid that they don't understand code and don't know how to read or something like that. It was just so complex that even while I was working on that implementation, I needed constantly to check up with the diagram, with the UML to understand which class is doing what, which one is responsible for what, and so on. So imagine going back into that code without having the diagram, trying to understand and sort out things, what is done where and why and all that stuff. It's not easy. So even now, after a year, I believe, I happened to talk with the director of engineering about this, and he said, in retrospect, he will never do that again. If we were to go back, he would not go that elegant architecture design and all that stuff, because it's not simple to understand, it's not easy to maintain, and it's definitely something that is more complex than it should have been. So here's the lesson for you. If you want to try something really complex, go for it as an experience, definitely. But don't do that, because down the line it will be so much harder to maintain it, and you don't work alone. You have to maintain that. You have that code has to be maintainable. Actually, recently there was a page that happened in the middle of the night for that code, and your brain is not fully woken up in the middle of the night and trying to solve something, trying to understand something. It's really hard. In the middle of the night, you want to sleep. You don't want to look in the code and try to understand what's happening. So that's another reason that you will never know when you have to look in that code and find the problem or answer a question or whatever you have to do in that code. You don't want that to be complicated and not being able to understand it from the first glance. So keep it simple. There's no need to complicate things. Life is complicated as it is. So keep it stupid simple. So that's the thing that I wanted to talk about in this video. I'm curious to hear if you have any other principles that you believe I should have added in the list. So feel free to add them in the comment section below. I'll check them out for sure. As always, I'm wishing you happy engineering, and it's time to design and develop something great. So go for it. Bye bye. Until next time, happy engineering.